Another just in case, question number 49. We have mass of an ice skater that is gliding due north at 4 meters per second. We're pretending like there's absolutely no kinetic friction. In other words, it's negligible. But there is static friction, which keeps our person from sliding sideways, keeps our skater in due course going north. But then the pesky wind from northeast exerts a force of 4 newtons on the skater. So if this is my skater here, bird's eye view, there are no forces other than normal and force of gravity, which I cannot show this way. Force that is directed like this, 45 degrees like that. Our motion is due north. So force of the wind is going to do a number on our skater and slow him down. They're asking us to figure out the speed after gliding for 100 meters. So we know that net work, and in this case, the only force that is doing work is the force of the wind. That will be change in kinetic energy, m over 2, and then we have our v final squared minus v initial squared. Work net is the work of the wind, so it's going to be 4 for force times 100 for the distance traveled, and then cosine. Now, mind you, this is not 45. That is 180 minus 45. So 135 degrees. In other words, I could see this is 90, this is 45, so that gets me 135. 400 times basically root of 2 over 2. And there's a minus because it's negative. Negative 200 roots of 2, which is like 200 times 1.4, so it's going to be 283 joules with a negative sign. That is the change in kinetic energy. So now if I double that, 2 times work over mass, that should be equal to v final squared minus v initial squared. So therefore, my v final squared is just 2 works over mass plus v initial squared. In our circumstances, it was 4 meters per second. 15 minus 566 over mass being, what was he said, 50 over 50, and then root of all of that, I got 2.2 meters per second. What is the minimum value of mu s that allows her to continue moving straight north? The diagram that I'm showing you is missing force of static friction, which will be in this direction, and that force of friction static should be equal to the x component of the force of the wind, which is 4 roots of 2 over 2, so 2 roots of 2, and then mu static is going to be force of friction divided by mg because she's flat on the ground, so 2 roots of 2 over 490.0058.